Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In my last lecture, I talked about properties of definite integrals, and we also discussed first three properties of definite integrals. Now, in this lecture, we will discuss the remaining properties of definite integrals. Here is the property number 4. Now, this is fourth property of definite integrals, which says that integral from a to b fx dx is equal to integral from a to b f of a plus b minus x dx, that is f of lower limit plus upper limit minus x dx. Okay, now let us prove this result. For that, we take LHS, and in LHS we put x equal to a plus b minus z. Okay, differentiating, we get dx is equal to minus dz, as a and b are constants. Also, when x is equal to a, we get z equal to b. When x is equal to a, we get z is equal to b, and when x is equal to b, we get z is equal to a. Okay, thus integral a to b fx dx is equal to integral, now when x is a, z is equal to b, and when x is equal to b, z is equal to a. We have f of, instead of x we have to write a plus b minus z, then instead of dx we have to write minus dz, so we write dz and we put minus sign here. Okay, that is further equal to, now if we interchange the limits, then the sign of the integral get changed, so we consider the upper limit as lower limit and lower limit as upper limit, then this minus sign get changed into plus sign. Okay, and we have f of a plus b minus z dz. Now, by property first of definite integrals, we can replace the variable z with some other variable. So in this case, we replace it with x, and we get a to b f of a plus b minus x dx. This proves the result. Thus, we have proved that integral a to b fx dx is equal to integral a to b f of a plus b minus x dx. Okay? Now, let us take a special case of this property. Now, we take a special case of it. If a is equal to 0 and b is equal to a, then we can write 0 to a f of x dx is equal to a is 0, b is a, f of a is 0, b is a, so we get 0 plus a is a minus x dx. Okay, if we have an integral from 0 to a fx dx, this is equal to integral 0 to a f of a minus x dx. That completes the result. Now let us discuss one more property of definite integrals. Now this is fifth property of definite integrals, which says that integral minus a to a fx dx is equal to integral 0 to a fx plus f of minus x. Okay, now let us prove this result. For that we take LHS and we will prove that this is equal to RHS. Now in LHS we have integral minus a to a fx dx. We know that if we have points minus a and plus a, then there is a point in between, that is 0. So we can break this integral minus a to a fx dx as integral minus a to 0 fx dx plus 0 to a fx dx by property number 3rd of definite integrals. Now we name this as equation first. Okay. Now put x equal to minus z in second integral. We will put it in first integral. In first integral on RHS. Now in this integral we put x equal to minus z, so we get when x is equal to minus z, dx is equal to minus dz. Okay, so we can write when x is equal to minus a, we get z equal to a. So we write, let us first write the integral, which is minus a to 0 fx dx equal to integral. Now when x is equal to minus a, z is equal to a, and when x is equal to 0, z is equal to 0. Then we have f of, instead of x we can write minus z. Then we have dx, instead of dx we can write minus dz. So we write dz minus times. Okay, that is further equal to, now if we interchange the limits, then the sign of this integral gets changed. It is minus here, so it becomes plus. So we get 0 to a f of minus z dz. Now we can replace this variable z with any other variable. So we replace it by x. We get 0 to a f of minus x dx. Okay. Now we substitute this in equation first. Now we can write integral minus a to a fx dx is equal to integral. Now instead of this integral minus a to 0 fx dx, we can write this integral 0 to a f of minus x dx plus we have this integral 0 to a fx dx, or we can write it as integral 0 to a, it's integral 0 to a, then we have fx plus f of minus x dx. As we know that integral of sum is equal to sum of integrals, thus we have proved that integral minus a to a fx dx is equal to 0 to a fx plus f of minus x dx. This proves the property number 5. Now here is the sixth property of definite integrals. Now this is sixth property of definite integrals, which says that integral minus a to a fx dx is equal to twice 0 to a fx dx if fx is an even function, and this integral is equal to 0 if fx is an odd function. Okay, now let us prove this result. We will use property fifth to prove this result. Now from property fifth we have, from property 5 of the definite integrals, we have integral minus a to a fx dx is equal to integral 0 to a fx plus f of minus x dx. Okay, now if fx is an even function, then we know that if fx is even function, then we can write f of minus x is equal to f of x. Now thus integral minus a to a fx dx is equal to 0 to a f of x plus, now instead of f of minus x we can write f of x if fx is an even function, so it is f of x dx. Now f of x plus f of x is 2 times f of x, so thus we can write it is equal to twice integral f of x dx with limits from 0 to a. Okay, now this proves the first part, that is when fx is an even function. Now we will prove the second part, that is when fx is an odd function. Now if fx is an odd function, then f of minus x is equal to minus times f of x. Okay, so we can write integral minus a to a fx dx is equal to integral 0 to a fx plus, now instead of this f of minus x we can write minus times f of x if fx is an odd function, so we can write here minus times f of x dx. Now we have plus fx minus fx, so they cancel each other, we get 0. Okay, so this proves second part, Thus integral minus a to a fx dx is equal to 2 times integral 0 to a fx dx if fx is an even function, and this is equal to 0 if fx is an odd function. That completes the result. Now let us discuss the seventh property of definite integrals. Now this is seventh property of definite integrals, which says that integral 0 to 2a fx dx is equal to integral 0 to a fx dx plus integral 0 to a f of 2a minus x dx. Okay, to prove this result, we take LHS and we show that this LHS is equal to RHS. For that, we have LHS, that is 0 to 2a fx dx. This is point 0 and this is point a, sorry, 2a. Then there is point a between these 2 points. Now we can write this integral as 0 to a integral 0 to a fx dx plus integral a to 2a fx dx. Thus we break this integral 0 to 2a fx dx into integral 0 to a fx dx plus integral a to 2a fx dx. Now we put x equal to, let us name this equation as equation first. Now put x equal to 2a minus z in second integral. In second integral on RHS. Okay, then we have dx equal to minus dz on differentiating x and z. Also, when x is a, when x is equal to a, we get z equal to a. Z is equal to a. And when x is equal to 2a, we get z equal to 2a minus 2a, that is 0. We get z equal to 0. Thus we can write this integral a to 2a fx dx equal to integral, when x is a, z is a, when x is 2a, z is 0. Then f of, instead of x we have 2a minus z, and instead of dx we have minus dz, so we write dz here and we put minus sign here. Okay, now on interchanging the limits, the sign of the integral get changed, so we can write it as integral 0 to a. So this minus sign gets changed into plus sign. Then we have f of 2a minus z dz. Also, in definite integrals, we can replace the variable z with any other variable. So here we replace it with variable x and we get integral 0 to a f of 2a minus x dx. Now substitute this in equation first. We get so this is equal to 0 to a fx dx plus integral. Now instead of integral a to 2a fx dx, we can write integral 0 to a f of 2a minus x dx. Okay, and this proves the result. Thus integral 0 to 2a fx dx is equal to integral 0 to a fx dx plus integral 0 to a f of 2a minus x dx. Okay. Now let us take a special case of this property. If we have f of 2a minus x equal to f of x, then integral 0 to 2a fx dx is equal to 0 to a fx dx plus 0 to a. Now instead of f of 2a minus x, we can write f of x dx, which is further equal to twice 0 to a f of x dx. Also, if f of 2a minus x is equal to minus f of x, then integral 0 to 2a fx dx is equal to 0 to a fx dx. Then we have plus 0 to a f of 2a minus x dx, but instead of f of 2a minus x, we have to write minus times f of x. So we get minus times integral 0 to a fx dx. These two integrals cancels, so the result is 0. Okay, so in case f of 2a minus x is equal to f of x, then this integral is 2 times 0 to a f of x dx, and in case f of 2a minus x is minus times f of x, then this integral is equal to 0. This proves the result. Now in my next lecture we will evaluate some definite integrals using properties of definite integrals. Till then, take care of yourself. Thank you.